kind of set that aside. I have found that math can really take your mind off other things if you allow it to. All right, so the reason I want to finish this problem is because I want you to understand that no matter how scary a problem looks, you can still do it. You can do it. So, yesterday we had gotten to the point where we said the area of this whole figure would be the area of the square, which is x squared, plus the area of the semicircle, and that was 1/2 pi r squared. We talked about this before. And the radius, since that is x, the radius would be half of x, or x over 2. So that area is 1/2 pi x over 2 squared. And that has to add up to, those two areas together, add up to 200, according to the problem. So this is what our equation looks like. All right? Now, yesterday, did I clean that up? I did. This is where we stopped, right here? Okay. We're going to go to our calculator. So if you want to clean that up, that does clean up a little bit, but it's still going to be yucky. So I'm just going to leave it like this, and I'm going to go to my calculator. And if I'm leaving my equation like this, then I'm going to type in this as y1 and this as y2. And then I will graph them and look for where they intersect, right? So here we go. y1. Now I already have something in there, so clear it out if you do too. And we're going to type this. We're not going to panic about it. Yes, it's not very pleasant, but it doesn't matter. Type x squared. You know where our x is, right? X squared plus. Now, I type 1 divided by 2. If you prefer to type 0.5, that's fine. You can do that. Either one. I'm just going to type 1 divided by 2. And then I'm going to type my pi. And my pi is right under my clear button. It's a second. You have to second pi. Okay? And then I'm going to put my parentheses. And in the parentheses, I'm going to put x divided by 2, because that's what I got. I'm going to close the parentheses. And I'm going to hit my square button. So now I have typed this in. So I'll go down to y2. And type 200. Now, if you hit graph at this moment, go ahead, it won't hurt anything. You're not going to see anything. Because, does it make sense to you that your second equation is y equals 200? So where is y equals 200? Isn't y equals 200 clear up here? And the window you currently have set up is from -10 to 10. That's what, this is the part you're looking at right now, because that's what we told it to do. So let's change that. First of all, x is going to be a positive number. Would you agree with me? So in my window, and when I say window, I mean x min, x max, y min, y max, which we are currently using as tens. I know my x value, whatever it is, it can't be negative, so I'm going to make that a 0. Does that make sense to you? It's not going to hurt anything to leave it -10, but I'm trying to make my window fit my problem. So I'm going to set it at 0. Okay? Now, what about x max? I really have no idea. So you can pick a number. Maybe, let's try 20. I don't know. So X min is 0, X max is 20. Now, I need to get my Y's up to the 200 range, right? So I'm gonna set my Y's at, oh, let's say 100 to 300. Now I'm gonna hit graph. Now, you don't care what shapes you have. What is the only thing you need to see? And do you see it?
Yeah.
Do they cross?
Yeah.
Now, I am 63 years old. I teach math for a living. I do stuff on my calculator all the time. Some of those numbers are just like guesses. I'm gonna put in a Y min and a Y max. I'm gonna hit graph. If I don't see an intersection, then I'm gonna go back and try new numbers. I tried to be logical because I had a 200 right here, so I tried to be logical about it. But your job is to see an intersection. As soon as you see it, you're gonna find it. We don't care what your window is. Just make it so you can see your intersection. So how do we do that again? Second calc, intersect. The cursor should come up on the screen. If you don't see the cursor, the calculator tells you where it is. It gives you the coordinates. So move it the direction you need to move it till you see it. Press enter. Move it to the other side of the point of intersection. And I got X equal to 11.98. That was my point of intersection by X. I need just the X, I don't need the Y. If you are struggling with this, people, you need to get in here for office hours, all right? I actually haven't heard yet about a meeting tomorrow. Any day that we do not have a meeting, I'm in here, all right? So I may be in here tomorrow morning. I don't know, sometimes they don't let us know till later, but I will be here tomorrow. If you want to stop by, you are welcome to. I might not, if I'm not in here, it means I did have a meeting, but, okay? All right, so this was a terrible looking equation, right? Terrible. We didn't worry about it. We typed it in and let the calculator do its magic. All right, couple more things in P5 and then we'll be done, ready to move to P6. Find the center and radius of this circle. Now, some of you were thinking, Mrs. Ford, we already did this. Yes, we did, but the equation of the circle looked like this. This is called the standard form of the circle. And when it looks like this, then we know our center is where?
Oh, 4, -1.
4, -1. And we know our radius is the square root of that number?
6.
Everybody remember that? That's kind of old news. Well, this is the same directions. Find the center and the radius, but tell me what's wrong with this equation. It is not in standard form. So if you're going to be able to look at it and find this stuff, your equation has to look like this. All right? So what do you think we're going to do? Meg?
You're gonna solve like for completing the square.
We're going to complete the square. And we're going to do it twice. We're going to do it on the X's and the Y's because we want to build squared quantities. So to prepare to complete the square, I'm going to rewrite my problem, just rearrange. I'm going to put the X's together and leave a blank because we know when we complete the square, we have to find a number to add in there, right? Now I'll group my Y's together. Leave a space because I need to complete the square on that. And then, over here I have a 5, but I also have 2 blanks, because whatever I add to the left side, I have to add to the right side. Now, I've done nothing except to rearrange. Is everybody still with me? All right, so now I'm ready to complete the square. So we take half of 8 and square it. So half of 8 is, squared is, 16. Both sides, 16. Same thing here. Half of 10 is, squared is, both sides. Now, see this guy right here? He's a perfect square. What square is he? X minus 4? And what square is my y? He is also a square. He is y plus 5. And then I'm gonna just add all that up, and that is 46. Can we tell the center and the radius now? Where's the center?
4, -5.
4, -5. That's it. It's the opposite of what's in the parentheses. What's my radius? Square root of 46, which does not break down. Don't break that down. Some of you are thinking, well, 46 is 2 times 23. It is, but if you're gonna break down a radical, what do you have to have? 2 of something, and you only have 1 2 and 1 23, so it doesn't break down. The radius is root 46. Okay, how do you feel about that? Manageable? All right, let's do the last one then. Everybody at your seats do it. Is there a volunteer who would come up and do his or her work on the board? And it can be one person, or it can be you and a partner if you prefer.
I volunteer.
All right, come on up. I'll write the problem for you, then you take over. All right, here you go. What are the rest of us doing? We're all working on it, right? Look at him go. He's doing great. -2, -3 for a center.
Yeah. Yep. I forgot what I did.
You need the radius. So let's not put it equals 23, but that's your center. Now what's your radius? You do. Yeah, radius is the square root of 23. Everybody okay with that? Not hard, not hard at all. All right, P5 is due Friday. P5 is due Friday. So mark your calendars, whatever you need to do. That is P5. Luckily, P6 is probably the easiest section of all. it is all about doing stuff with complex numbers. So 3 plus 2i, a plus bi, x plus yi, those are called complex numbers. Your textbook, throughout the whole book, because we come back and look at this again in later chapters too, your book always labels them, names them, and says, okay, my first complex number, which I'm gonna call z sub 1, that's just the way they identify it, name it. Z sub 1 is this, and z sub 2 is this. So when they say, find z sub 1 plus z sub 2, that just means we're gonna add those two numbers together. Does that make sense to you? Gonna add them together. How do you think you do that? Combine like terms. So that would be, our answer would be 7 minus 3i. Right? Next one says subtract them. Now, when you're doing a subtraction, it's just as easy. But remember, it's 3 plus 2i minus 4 minus 5i. And those parentheses are necessary because you're subtracting the whole number, right? Which means what? Distributing the negative, yeah. When you subtract, you have to distribute the negative. Then it's just the same. We end up with negative 1 plus 7i. What do you think 3 z sub 1 is?
You multiply z sub 1 by 3.
Exactly. And so what would be our answer?
9 plus 6i.
Yeah. I told you this was easy. This is not hard. Don't let the notation bother you. You're basically collecting like terms. Now D says we're gonna multiply them. Okay. What do you think that's gonna involve? Think about what that looks like now. We're multiplying them. So it's 3 plus 2i times 4 minus 5i. How do you think I'm going to do that? Katie? I'm gonna foil it. Absolutely, I'm gonna foil it. So foil F first, outside, inside, last. It's distributing. So here we go. I'm gonna get 12 minus 15i plus 8i minus 10i squared. Remember, when you multiply an I times an I, you're gonna get an I squared. Just like when you times an X, you get X squared. But I squared is special. Who remembers? Charlie?
Doesn't it become plus 10?
Okay, because I squared is negative 1.
Yeah.
So this is what we need to know. But Charlie's exactly right. If I squared is negative 1, then when I times these together, that is going to become plus 10. Would you agree? So now that plus 10 can be combined with the 12. And these two were already like terms. So there's my answer. Right? All right, and finally we've got z sub 1 divided by z sub 2. Anybody remember anything about this? This side of the room remember anything? I got a few memories over here. Anybody over here remember anything?
Would be 4 plus 5i? We multiply both by that?
Exactly. We multiply the top and the bottom by 4 plus 5i. So we look at the denominator and we change the middle sign of it. So since it was originally 4 minus 5i, we're going to multiply by 4 plus 5i. Anybody know what that's called? It's not the inverse, although that's a great guess. It's called the conjugate. You've heard that word before? It's called the conjugate. The conjugate of a complex number is this exactly. You just change the middle sign. So if our number were a plus bi, the conjugate would be a minus bi. That's just the name of it. All right, so now we have massive foiling. We have to foil the top and the bottom. So go ahead, let's see what we come up with. When we foil the top and the bottom. Did anybody get a numerator? I got 2 plus 23i. That you got on top. And then on the bottom I got 41.
Yeah.
That's why we did what we did. You cannot have an I in your denominator. So remember, this was the original problem. You can't have that down there. And the way to get rid of it is to multiply by the conjugate, because this is what happens every time. Quick comment. Obviously, nothing cancels in this problem. Sometimes we get a little crazy though. If we had something like this, sometimes we think, oh, 6 over 12, I'll go ahead and cancel. No. This is another one of those 3-part problems, 3 parts, it's like a triangle. You can't cancel unless you can cancel out of every part. All right? So if we had 6 plus 4i over 12, that we can take a 2 out of everything and reduce it. But don't reduce unless you can do it all 3 places. All right. A couple more and we'll go to lunch. I know you're anxious about that. Anybody have a question about this? Okay. Tell me what you think about the square root of negative 16 times the square root of negative 25. Do you think anything about that? Okay, I saw it kind of go up.
Do you take the square root like normally, but then you add the I because you take this the square root of negative 1 out of
Exactly. Remember, I is the square root of negative 1. So when you have the square root of a negative, the first thing you do is pull that negative out, but it becomes an I. And then Katie said take square root like usual. Yeah, what's the square root of 16? So this is just going to be 4i. What's this one going to be? Same concept. This one's going to be 5i. And we are multiplying them. So we will get 20i squared. I squared is negative 1, so the final answer to the problem is negative 20. This one is identical. So we're going to have I radical 3 times I radical 15. And I'm still going to have my I squared. But now I'm going to have the square root of 45. I squared is -1. And does 45 break down? It does. What does it reduce into? 3 radical 5. So -3 radical 5 is the final answer to that problem. Alright. Alright, we're gonna do one more, then it'll be lunchtime. This is a doozy though. Look at 3A. What a monster. Emma, what do you think we might want to do first? There's a lot to do in this problem. What do you think?
Get rid of the parentheses.
So how would I do that?
Foil.
Foil. So I agree with them. I think that's the best way to start. There's more to do, but I think her idea to foil the top is splendid. So here we go. First, outside, inside, last. Not doing anything to the bottom yet, just leaving it be. So how does my top simplify? This becomes a +2. So 4 plus 3i. Is that good? Now what? Multiply by the conjugate, right? Of the denominator, always of the bottom. So we're gonna multiply by 5 minus 2i. We got 2 minutes to get all this foiling done. We can do it. Because we are the best. And I need your help because it's entirely possible and probable that I've got a mistake in there somewhere.
I got the same.
You got the same thing? Well, then it must be right because we would not that. Alright. So we are gonna be back at 49. You're in your seat at 49. Go to the bathroom. Whoever you do in our seat at 49.
Charlotte. Charlotte.
Let me make you swim again.
Charlotte.